Welcome to CSGuitars, the science of loud. As guitarists, we love effects pedals, building boards both big and small and having access to a massive array of sounds right there under our feet. However, powering all of these pedals safely, efficiently, and most importantly noiselessly can be challenging, and this is compounded by the fact that pedal power supplies are often accompanied by a lot of jargon about electricity that you might not understand. For this Science of Loud video, I've teamed up with French pedal manufacturer Anasounds, who in November announced these, the K+ modular power source, which aims to be the anatomically correct heart of your pedal board. Now, I'm not interested in sitting here and promoting this product because frankly it would be a waste of my time. Head across to the website and read the specifications. This thing sells itself. There's no doubt that this is the ultimate pedal power supply. So what I want to do instead with this video is make a comprehensive guide to electricity terminology, power supply technology, and everything else you need to know to properly power your pedals regardless of what power supply you're using, although it should probably be this one. Before we can get into discussing power supply options and plugging in pedals, we firstly need to understand the basic fundamentals of electricity. By far the most asked questions about powering pedals comes down to musicians not understanding the concepts and importance of voltage, current, and polarity. Getting these wrong can result in broken pedals, so it's very important we understand what each of these terms mean. Voltage is the potential difference between both ends of a circuit which will push electricity on its way. Having the correct voltage for your device is critical to safe operation. It's kind of like electrical pressure, and you can think of it like water in the plumbing of your house. You need to have sufficient pressure to push the water through the pipes so that when you turn on the tap, something actually comes out. Too little pressure and you'll get barely a dribble, too much pressure and you'll burst your pipes. Voltage in an electric circuit is no different. Too little voltage and the effect won't be able to power on. Too much voltage and you will rupture components in the circuit, leaving your pedal ruined. The vast majority of effects pedals will operate at 9 volts, but some others will have different voltage requirements. Always check that the voltage your pedal is expecting and the voltage your supply is putting out match before plugging anything together, as the pedal will receive whatever voltage the supply is spitting out. Electric current is the flow of charge around a circuit. A pedal will have a specific amount of current it requires to operate, usually given by a nominal rating in milliamps. Analog pedals will often only draw a small amount of current, between 20 and 50 milliamps, while digital pedals will require a little bit more, 100 milliamps upwards. Any pedals that run valves will require more current again, often up to an amp or two. Unlike voltage, however, it's the pedal, not the supply, that determines how much current it will take. While each socket on the supply might have 2 amps available to provide, any pedal connected to it will only take what it needs. To go back to our water analogy, the current rating of the supply is like a reservoir. It can hold a lot of charge, but any circuits connected to it won't take the full reservoir's worth at once. They will only be able to draw what they need at any point in time. Meaning that if you've got a 50 milliamp draw pedal and you connect it to a 2 amp socket, that pedal will only take 50 milliamps, leaving the majority of the juice untouched. Current can either be DC, direct current, or AC, alternating current, and that leads us onto a conversation about polarity. DC or direct current is the most common way to power pedals. Batteries are DC, as are power supplies dedicated to pedals, and both have 2 terminals, positive and negative, which supply power to the device. However, it is possible to swap these terminals round and reverse how power is supplied to the pedal. Effects pedals are most commonly centre negative, as denoted by this symbol, which is a bit of an electrical oddity as most other consumer-grade electronic devices are centre positive. Notice the difference in this symbol. This doesn't mean that centre positive polarity pedals have their circuits wired backwards. Ground will still usually be on the negative line regardless, but this convention of having the positive terminal on the outside of the power connector was adopted for guitar pedals due to the way that the barrel of the power jack is used as a switch to disengage the internal battery. Getting the polarity wrong by inverting the battery or using the reverse polarity supply to what you're supposed to will either prevent the pedal from powering on or damage it if it doesn't feature polarity protection. It's also possible for electricity to be AC, or alternating current. This is the type of current supplied from your mains outlet where the current flows in both directions, back and forth at a frequency dictated by your country's power grid. In Europe, that's 50 Hz. In America, it's 60 Hz. Since swapping the two terminals of an AC supply for a single device looks identical, we can consider AC as having no polarity. While there are some pedals that power from AC, they are fairly uncommon. However, you can't power an AC pedal from a DC supply or vice versa, and doing so could lead to damaging the pedal. Always look for these symbols to know which one your supply is. I suppose we should very quickly address how a power supply unit manages to take the 230 volts AC from your main supply and convert it down to a 9 volt DC to power your pedals. The first part of the process is transforming the mains voltage to a smaller AC voltage. This is usually done, appropriately enough, by a transformer. The voltage on the primary coil induces a voltage in the secondary coil proportional to the ratio of the turns between both of the coils. That smaller AC voltage needs to be converted into a DC voltage. A rectifier achieves this, effectively preventing the voltage ever flipping into the negative region. The rectified voltage then needs to be filtered to remove ripple from the power. This is done by filter capacitors and is an extremely important part of the process. Any ripple in the voltage line can cause all sorts of problems, including noise, so it's very important to eliminate it. Finally, voltage regulation will ensure that a consistent 9 volts will be supplied regardless of how much current the pedal tries to draw. The trifecta of voltage, current and polarity all having to be correct should highlight exactly how risky it is to try and power your pedals from any old power supply you happen to have lying around. We've all got a drawer full of old power supplies that we've taken from laptops or other devices over the years, and the temptation could be to save some money and power our pedals from one of these instead. But if you're going to do that, there are a couple of things you need to consider. Firstly, the chances are that these random power supplies won't have the correct voltage, current or polarity to do the job. Always read the label and look for the output ratings to be sure what this is going to supply before blindly plugging it in. A 15 volt center positive supply is not going to be healthy for your 9 volt center negative pedals. Also, it's almost a certainty that these cheap PSUs that came with whatever device you had weren't made with an audio application in mind, hence will be noisy when you plug your pedals into them. One reason why pedal-specific power supplies are more expensive is because it requires careful design and filtering to ensure the power is stable and not injecting noise into your signal chain. These cheap PSUs that came with whatever device you had years ago weren't made to the same level of care because they didn't need to be. They just needed to be cheap and charge a battery, so it didn't matter if they were noisy. Plugging them into your pedals could be less than ideal. Dedicated pedal power supplies like the Anasounds K+ units are a fantastic way to power a lot of pedals. They have a large number of outputs so you can connect many pedals at the one time. Some of these outlets allow you to change the voltage so you can select which voltage they output. They have a large amount of current available on each of the sockets so even your thirstiest pedals will be satisfied. These two units can be chained together to expand out the number of sockets you have as your pedal collection grows, and as these were designed with an audio purpose in mind, they provide quiet, stable power that won't inject noise into your signal. There's this misconception in the pedal world that daisy chain connectors, like this one, are terrible and noisy, which just isn't the case if you're using them correctly. Daisy chaining pedals together allows you to power multiple pedals from a single outlet on the supply, which is really advantageous for extending the scope of your power supply, but you need to know which pedals are best suited for this application or you could run into some problems. Since everything on the daisy chain is sharing the same outlet, the total current draw from all the pedals connected to it mustn't exceed the current available from the socket. With the Anasounds K+ and its monstrous 2 amps per output, this isn't much of an issue. Even 5 pedals drawing 100 milliamps apiece only totals 500 milliamps, a mere quarter of what one of these sockets can provide. But if your power supply can only dish out 250 milliamps total, you're going to have to look for some pedals that draw less current. Analog pedals, particularly overdrives, are great candidates for this as they can draw as little as 15 milliamps sometimes. A daisy chain of only a few low current draw analog effects is the ideal solution. The problems with daisy chain noise either come from a cheap power supply or certain pedals that will introduce fluctuations into the power line. Since power is being passed down from pedal to pedal in a daisy chain, if one of those connected pedals introduces a voltage ripple, then that ripple will carry through to all the other pedals and cause them to act up and be noisy. Digital pedals, especially older ones, are common culprits of introducing power-induced noise. So if you're running a mixture of digital and analog effects, be sure to keep the digital pedals out of any daisy chains you're using and on their own isolated or regulated sockets depending on the technology your power supply operates on. Switch mode is often a dirty word when discussing pedal power, as most people will associate it with noisy pedals, but just like daisy chains, this isn't necessarily the case. In fact, it's completely possible to make noiseless switch mode supplies. You just need to be willing to put in the time, effort, and money to manufacture them that way. How switch mode supplies work is very interesting and quite beyond the scope of this video, but to summarise their advantages, they are extremely power efficient, lightweight, don't dissipate much heat, and if you don't care about noise in your power line, can be made extremly cheaply indeed. That's why any electronic device that you buy that requires a charger or power supply will likely come with one of these cheap switch mode wall wart style power supplies. The low cost and low weight makes them ideal to throw in as an accessory, as it doesn't add much to the cost or shipping weight of the item. However, because of the electronic switching technology on which they operate, if you don't manufacture them to filter out all of that voltage ripple, they can inject switching noise into the power line, wreaking havoc with audio systems, particularly if that switching frequency encroaches on the audible range. This isn't an issue if the power supply is intended to power a battery charger or a label printer, but once you start powering your pedals from one of them, that's when the problem's going to arise. By spending the time and money to design proper filtering to eliminate voltage ripple and switching noise, a switch mode supply can operate silently and offers a number of significant advantages over transformer isolated supplies. With such high power efficiency and low heat dissipation, it's possible to offer much higher currents from a switch mode supply, which is the reason these K+ units can offer 2 amps per output, even at 18 volts. Each of the outlets is individually regulated by its own switching chip, meaning that any voltage ripple from a pedal connected to the supply won't carry its way through to anything else connected to the supply box. And because the voltage is regulated in DC, this means we can remove the AC-DC conversion from the supply box entirely, instead having that happen in its own power brick, discrete and distant from the pedal board. This is advantageous as it removes 50 or 60 Hz noise from being injected from your supply, removing entirely the most common form of interference-borne noise. However, no power supply technology is perfect. One drawback of having a well-made audio quality switch mode supply is that while the voltages are individually regulated for each output, the grounds are still common between them. This can, in rare cases, introduce noise due to ground loops, where multiple devices connected together may have different ideas about what potential ground should be held at. While having all of your connected devices referencing the same ground is usually a great idea, sometimes the paths which currents take along the common line can drop the potential enough between 2 points to generate ground hum. The likelihood of encountering ground loops increases with the complexity of your rig and how many different devices you've got all connected together and then going back to power. Although in my experience at least, ground loops aren't the most common source of noise when powering pedals, which still makes these high quality switch mode supplies an extremely robust, lightweight solution delivering near unlimited power. Isolated supplies are often hailed as the holy grail of power supply technology due to their use of transformers at each output which electrically isolate the ground connections from all the others. But as previously stated, no power supply technology is perfect. While isolated supplies protect against ground loops, they do very little to prevent against other forms of power-related noise. The transformers which provide the ground isolation unfortunately still have to work with AC, bringing 50 or 60 Hz EMI with them. Having AC so close to the power outlets means that mains frequency interference can still be present, and you'll have to consider very carefully where a PSU of this type will be mounted. Some pedals, especially wah-wah pedals, when placed above or alongside an isolated supply can become an antennae for that kind of noise. A further drawback of isolated supplies is that the current they provide is limited compared to switch mode. Now, for the vast majority of pedals which are relatively low current draw devices, this won't be an issue, but for some really power hungry pedals, isolated supplies might not cut it. One place isolated supplies are absolutely essential though is when using a positive ground pedal. Positive ground means that the ground within the effects circuit is being held at positive potential with respect to the supply voltage. Now, admittedly this is extremely uncommon in effects pedals, really only cropping up with vintage or vintage-inspired boutique fuzz pedals, but such an effect can't function in a daisy chain or non-isolated supply with other pedals on a common ground. A positive ground pedal either requires its own battery or power supply, or an isolated supply where each ground can't interfere with the others. This is a very different issue from reverse polarity or center positive polarity pedals, where you can just use a polarity inverting cable and all the pedals will get along just fine. Although these terms are often confused, as positive ground pedals are also extremely likely to be center positive polarity. This again has to do with the way that the barrel of the power jack disengages the battery within the pedal, but it's also completely possible to have a negative ground center positive polarity pedal or a center negative polarity positive ground pedal. If all of this power supply talk has got you confused, then I want to let you know that powering your pedals from batteries is a completely legitimate solution, and in some circumstances may even be your best option. The advantage of using batteries is that they are clean, DC power with no ground connection. Powering a pedal from a PP3 battery eliminates any risk of ground loops or interference from a dirty mains supply. If you have that one pedal that just doesn't like to play nice alongside all the others when connected to the power supply, then powering it from a battery will make your life a lot easier. One piece of recording studio advice is to power your pedals from a battery where possible. This will save you a lot of time in an expensive studio session trying to troubleshoot where all the noise is coming from now that you've plugged your pedal board into the studio's mains supply. Batteries are the cleanest form of power, if a little bit inconvenient. There's nothing particularly power hungry here with the exception of the 2 notes lead preamp, which is running a preamp valve and requires 12 volts 500 milliamps. So I've got that connected to the larger K+ with the switch set to 12 volts. The Traverb is also asking for 310 milliamps, which is a little bit thirstier than standard, but nothing that will trouble these power supplies. I've got a mixture of digital and analog effects powering from this. The digital pedals, the tuner, compressor, phaser and the Traverb are all connected to the smaller K+, and all the analog pedals are connected to the larger one. The bottom row of pedals is feeding into the front end of the amp, while the top row is going into the effects loop. Now, while this isn't a particularly complicated setup and many of the pedals here are very basic low current draw effects, it's the mixture of different pedals all powering from the same source that we're here to inspect. Even with all 10 of these pedals connected, the K+ still has sockets to spare and plenty more current available to use, so I could add a few more big effects here without issue. This is running silently in terms of power noise. Sure, we still have to compete with the likes of single coils picking up EMI from the studio lights, or system noise within the pedals themselves like gain hiss for example, but in terms of power, there's no ground loop noise, there's no voltage ripple, and there's no switching noise. This is super clean. With the noise gate here biting down on the gain hiss coming from the high gain preamp and humbuckers to defeat the 50Hz EMI being picked up from the environment, this is a super quiet rig with power to spare. Hopefully this has been a very detailed discussion on power supply technologies, their pros and cons, and how you can power your pedals effectively without incurring noise in your signal chain. These Anasounds K plus PSUs that I've been using throughout this video are fantastic. Classy looks, low profile design, they come with mounting brackets to mount them to your pedal board, spare engraved front panels with the text inverted in case you want to mount them upside down, and most importantly they'll power just about anything and do it silently. They come with all the cables you will ever need in a variety of lengths, and I really can't say enough good things about them. These are slick power supplies that have been well thought out to meet the needs of even the most demanding musicians. Don't forget to check the links in the description to find out more information and check the price for yourself. Also, don't forget to click all the buttons you're supposed to make this video viable to the ever-changing whims of the YouTube algorithm. Keep it loud and stay safe. Unlimited power!